Hello and welcome to our first lecture video. This video corresponds to Chapter 1 in the Xi book, the introduction chapter. So in this chapter we're going to go over what's an algorithm, what is programming, and we're going to write our first program. So let's go ahead and jump right in. Alright, so we start off looking at the definition of an algorithm. It's a word used by programmers when they do not want to explain what they did. Now, hopefully you found that funny because it's not the real definition. You'll see the real definition as you read the book, but essentially what an algorithm is a set of steps to accomplish a task. We're already familiar with writing steps to accomplish tasks. For instance, if we are a chef or a cook, then we maybe have developed some recipes. A recipe is simply an algorithm in that case. Likewise, if we're driving and someone asks us how to get somewhere, then we provide them with a set of steps to get from point A to point B. And those set of steps in programming is considered an algorithm. Okay, so what is programming? Well, programming is really the process of writing instructions that can be read by a programming language. The programming language, what it does is it reads and executes those instructions. It has control over the computer and it's able to tell it to execute those instructions. Like I said before, really similar to recipes. It involves computational thinking, so we have to be able to do something called task decomposition. We need to be able to take a task and break it down into smaller, more atomic pieces. And those pieces, when we put them all together, is going to lead to an algorithm. Alright, so let's look at an example. This is, in case anyone watches The Big Bang Theory, this is the friendship algorithm from Dr. Cooper, who's one of the characters on the show. So this is a way to express an algorithm, and it's actually a good way as you're first designing an algorithm to go ahead and lay it out on paper. What we're seeing here is called a flow chart. So we can start up here at the very top, and we see place phone call, and we just need to follow the arrows. So these squares, when it comes, what do these mean for a flow chart, is like a statement. Do something. So place phone call. Now, diamonds are decisions. So you'll see there's two paths leading from a diamond, and we need to make a decision and follow one of these paths. So if we're placing a phone call and we're asking someone, are you home? If so, we'll follow yes. I would like you to share, or would you like to share a meal? So these parallelograms represent output, sometimes also input. So what we're seeing here is you would be saying, would you like to share a meal? So we'll follow and we'll lead right into a decision. What is the response? If it's yes, then let's dine together and let's be friends. If it's not, do you enjoy a hot beverage? Well, if you do, then let's figure out if it's tea, coffee, or cocoa, and whichever one it is, let's have that and then be friends. But if not, we're going to lead into this area. Okay, so I think you probably get the picture by now. You can finish going through here and you can look at all the different paths that you can take through this flowchart. And that's essentially the exact same way as a program works. It just goes through and follows the arrows, so to speak. Okay, so I had mentioned earlier task decomposition. So here's a really simple example of task decomposition. Let's say our goal is to bake cookies. Okay, so you tell me, Professor Nance, I want for you to bake some cookies. So in my head, I'm thinking, all right, what do I need to do in order to bake cookies? Well, I can decompose or break down the task of baking cookies into 4 separate steps. I can stir some ingredients, I can place them on the baking sheet, I can bake it, and then I can eat it. Well, some of these tasks might need to be decomposed as well. For instance, if I tell you to stir the ingredients, you probably have a couple questions for me, such as what ingredients? What do you want me to stir them in? And what would you like me to stir them with? So we need to take this and break it down a little bit further. So stir ingredients could have the steps like acquire a mixing bowl, add some peanut butter, add some sugar, add some egg, and then stir. Once we get done doing these things, we would come back and proceed on to the next step. So place on a baking sheet. And we may need to decompose this task into something else as well, such as grabbing a spoonful of the dough and putting that on the baking sheet one at a time. Alright, so like I said before, this class we're going to be learning programming in a dynamically typed language, and that language for us is going to be Python. So Python is said to be a high-level programming language, which means its syntax roughly resembles the English language, and you'll see that. Hopefully it'll be very easy for you to understand what's going on. That's one of the big pros of using Python is its readability. So Python was first released in 1991. It was created by Guido van Rossum, who is still involved with the language today. His design philosophy was readability and having white space. So being able to take the source code for a program and give it to someone who's maybe not very well versed in Python or maybe is not even familiar with programming, they should be able to look at that and roughly understand what's going on. Now the white space thing, that'll become apparent as we go through the course, but it enforces that we use white space to denote certain sections of the program. Alright, so as you saw when you downloaded Python, there are two main versions of Python out there, Python 2 and Python 3. And you can see that Python 2 was released back in 2000 and Python 3 was released in 2008. Well, Python 2 is at the end of its life. That was initially set for 2015, but like most people, people are reluctant to change, don't want to change, have already written a lot of code in Python 2, and they leverage that code in their projects. So the end of life has actually been postponed until 2020. To go ahead and get you set up for that, though, we're going to just there's no sense in learning the end of life syntax. We're going to go ahead and start learning Python 3. And for the most part, what we learn is going to carry over and be applicable to Python 2. Really, there's just some syntax changes and some very small sort of changes in the language itself. Okay, so Python has something called an interpreter. That's actually what Python is it takes source code that we write, and we're going to write code in something that's sort of akin to a text editor. We could even write in a text editor if we wanted to. And the interpreter is going to open that file that we wrote, and it's going to read through it. And it's going to directly execute those instructions that we tell it to execute. Much like when we were going through the flowchart, as it hits an instruction, it's going to go ahead and do what that instruction says, and then it's going to move on to the next part of the flowchart, or in the case of source code, the next line in the program. Okay, so what is it really doing behind the scenes is translating this program into machine language. It's taking this high-level language that we write in a language that we know as Python and is converting that into the machine-specific language for the computer that we're running it on. So Python runs on Windows, Mac, Linux. It supports many other obscure operating systems. If you go on python.org, you can see all of the support that it has out there for various OSs. Let's see. Okay, and one of the things that I really like about Python is it provides us with an interactive interpreter. Alright, so what does that mean? This is some place where we can go and test code and we can watch it execute immediately. So kind of foreshadowing here, we can see down in this screenshot, I am in the interactive interpreter. And the interactive interpreter is usually denoted by these three greater than signs, and we call that the prompt. So it'll be prompting, waiting for us to input something, and we can input a line of code like we see here. So foreshadowing a little bit, this is how we output something or how we print something to the screen. It's called a print function. Functions similar to math, like x of or y of x or something like that. This is print of hello world. So hello world here is an argument to this function. And we're basically just telling Python what it is we want to print inside these quotes. And as soon as I press enter here, it goes ahead and it outputs that to the screen. And now it's waiting at the prompt again for me to do something. So there's a few ways that we can get into the interactive prompt. One way is via the terminal, which is what you see here. So if you're on Windows, terminal is pretty much the command prompt. Let's go ahead and load this up. Okay, so to get into the interactive prompt, I can type in Python, or in my case, I have Python 2 and 3 installed. So what I'm going to do is type in Python 3 so that I know that I get into the Python 3 interpreter. And now we see that prompt, the interactive interpreter prompt, and it's waiting for me to do something. And I can tell it to print hi. And we see that gets outputted to the screen. Now it's waiting for me to print something else. I'm going to say print by. And we can sort of come in here and we can test code out, we can paste code in, and see how it works. Now the other way, and probably the more preferable way for everyone to get into the interactive prompt, is to go through idle. So idle is the GUI IDE that we're going to be using here in the course. Now of course if you have another IDE that you prefer to use, that's perfectly fine too. When I do the lessons, I'm going to try to use idle just so that everything sort of follows along with what you're doing on your computer. So when we open up idle, it comes up, and this should look familiar. We're seeing pretty much the same thing that we see here. Python 3.5.2, version blah blah blah, GCC 4.2.1, some stuff about copyright, and then a warning. Now I'm not sure why, but in idle, when it first opens, you just need to click in here and press enter, and it'll bring you to a shell prompt. Okay, so once you're at a shell prompt, or an interactive interpreter prompt, you can go ahead and start running your code. And I think right now we can already see some of the advantages that come from using an IDE, an integrated development environment. So even though these two things are functionally equivalent, one thing you probably notice right off the bat is that this is just black and white. Over here I'm getting something called syntax highlighting. And we can see that some different parts of this, and we'll learn the terminology as we go through the course, but we have a string here which is denoted in double quotes, and we have our function, and functions are pink and strings are green. So as we go through and we're looking at source code, it's easy for these different parts to stick out to us and to show up for us. Okay, so we already talked a little bit about idle, just mentioned syntax highlighting. So IntelliSense is probably the next thing I want to mention here. Let me go back into idle. So obviously we're not going to be working in the interactive prompt all the time, because if that was the case, we would have to type in our source code every time we wanted to write a program. And typically when we write a program, we want to be able to have that packaged up in some way, whether it's source code or a compiled program, and give it to somebody so that they can run it. So in order to actually write what's called a Python script, which is just a file containing Python commands or Python instructions, we can go to File, New File, and you see we get essentially a blank text document. Okay? So every script that we write is going to have this comment at the very top. Now I know that that's a comment because it starts with the hashtag. So anything in this file that starts with a hashtag is going to be ignored by the interpreter. The interpreter is not going to try to execute that. But this first comment is a little bit important on Linux-based operating systems like Linux, Unix, Solaris, OS 10, Mac OS, basically anything but Windows. And what it does is it tells the operating system how to run this script. For Windows, Windows uses the file extension. So you can see in this example down here, this file is called hello.py, and that .py tells Windows to run this with Python. Well, Linux-based operating systems, they don't care too much about what your extension is. As a matter of fact, you could create a file without an extension, and it would be perfectly fine. The Linux operating system would be just happy with that. So what Linux-based operating systems do when you run a file is it'll open up that file and look at the first line and see if it starts with this hashtag exclamation point. And we call that a shebang. Some people call it a hashbang. I think there's a few other terms for it if you look it up. I think most people call that the shebang though. And not to get too technical here about what's happening, but this user bin env tells the operating system to look into your environment and find the executable called Python 3. And that's what you should run this script with. Alright, so what's important for us to take away from that is just to be sure to include this at the top of all of our scripts so that our scripts can be portable. Remembering back to what all operating systems is supported by Python, there's a bunch of them. There's Linux, Windows, Mac, and a few others. And with that portability, we want to be able to support as many of them as we can with the scripts that we write. So even if we're writing a script for Windows, we probably want to include this just so that we have full support on Linux as well and make it better for our users. Alright, so after that, we can start typing whatever commands we want. We can put in a series of commands, essentially infinite, depending on our memory, how much we can store. So let's go ahead and put in some commands here. Let's say print. We're already familiar with that one. So this is the IntelliSense feature that I was mentioning a second ago. When we type in a function name like print, and we open up the parentheses so that we can pass in what's known as a parameter, and in this case what it's expecting is a value of what to print, the IntelliSense comes up and lets us know what all we are able to say here. Okay, so there's a lot of extra stuff here that we don't need to worry ourselves with just yet. So let's just deal with the value. What would we like to print out? Hello world. And just to show you, we could have as many statements in here as we want, and statements all need to be on their own new line. Okay, so on a new line, print goodbye. Okay, so it doesn't matter what line these are on as long as they are on their own line and they are not indented or have any white space before them. Alright. Again, just to illustrate what is a comment, we can put comments in here with a hashtag, and you know, we might say start of my program. This line is ignored, and it's ignored because it's a comment. Alright, so let's save this and watch it run. So I'm going to save this, and what you may want to do is just somewhere on your computer create a directory that you're going to hold all of your CSCI 135 work in. So I might say new folder CSCI 135, and then in that folder I might create another one called chapter 1, and then in here I can save my file as whatever I want to call it. So hello world.py. So let's save that. Now that we got it saved, I can see the full path to where it's located. And at this point, we can go ahead and run it and see what the output is. So if we click on Run up here at the top or on the menu bar of idle, you'll have the option to run module. Now notice there's also a keyboard shortcut, F5. And you're going to probably want to commit that to memory because you're going to be running your module a lot as you go through and debug it. Alright, so let's go ahead and do that. If we run it, what you see happens is over here in the interactive prompt, it has restarted a script, and that is the script that we just wrote, this hello world.py, and it's going through and it's executing one line at a time. So it's ignoring the comments, it hits this print, we see hello world print out, ignores the comment, sees the print, and it prints out goodbye. Alright, so there's a lot of other neat features that we're going to get into as we progress through the semester. Smart Indents 1, auto completion, scripting mode, shell window, that interactive interpreter. We've already seen that feature. And there's also a debugger that'll help us out later on as we try to figure out why we're having errors in our program that maybe aren't very apparent to us. Yes, so just to show you, because I'm going to have several screenshots in the terminal as we go through the lectures, I want to show you how I'm running those. So also, to get out of the interactive interpreter, if you happen to open that up in a shell or a command prompt or terminal, the way to get out is to write exit, open close parentheses. Okay. So let me browse to where I just saved that file, and I think I saved it in my documents, CSCI 135, chapter 1. Okay, so there's my hello world.py file. If I want to run that with Python 3, and remember I have to put the 3 because I have Python 2 and 3 installed. If you just have 3 installed, then you could probably just run this as Python followed by the script name. Okay, so I'm going to put that back in there, Python 3. And if we press enter, what it does is exactly what we saw over in idle, is it just runs and it executes those commands in the script file. Alright, so the whole purpose of that is just to demystify where this is coming from. There's no expectation that you have to run this out of the command prompt or in a terminal. Definitely feel free to use idle and take advantage of the nice features that it provides us with. Alright, so let's hash out some vocabulary here. So, statement. What is a statement? Well, a statement is a program instruction. Such as before when we wrote print, let me just pull that up here. That is a print statement. This is a print statement. Okay, so there's two print statements here. An expression is code that returns a value when evaluated, and we're going to get into that a little bit more next week. But since Python is such an easy to read language, let's look at an example of that. If I say that dog age is, and someone's age is 12 years old times 7, that's an expression. What's going on here is this expression is going to be evaluated, so 12 times 7 will be figured out, and then that will be assigned to dog age. And hopefully that makes a lot of sense, because it's basically the same thing that we do in algebra when we say let x equal 2, or let x equal age times 2, or something like that. So that leads right into the next vocabulary term, which is variables. Variables is a way to reference a value that's stored in memory. Okay, so this right here, dog age, would become a variable, and this 12 times 7 would end up being stored in memory at a location referenced by dog age. Alright, so just to show you, now I can say print dog age, and I don't have to keep up in my head with what is 12 times 7 or what was the last value of dog age, because Python's going to handle that for me. Okay, so if we run that, F5 to run it, we can see it's 84, and that got printed out right underneath goodbye because of the order that it's located in. Okay, assignments. Assignments are used to create a new variable. They use the equal sign. We have an example of that right here where we were assigning what's on this side to that side. So we call the equal sign the assignment operator, and the order that the assignment operator works in is what's on the right hand side gets evaluated and assigned to the left hand side. Comments, these are optional, but they help to explain code. We've already seen a few good examples of that, as well as the shebang up at the top. Oops. Literal, so specifically a string literal here, is any text in the code that's quoted. And Python really doesn't care if you use single quotes or double quotes. It just wants for you to be consistent as you go through. So for example, hello world here is a string literal. This collection of characters, we call that a string in programming terminology. And the fact that the string is in quotes means it's a string literal. Yes, so could also be single quoted. So we could start that with a single quote and end it with a single quote. But notice when I had started it with a single quote and I ended it with a double quote that the color of this closed parentheses changed, and it changed from white to green. And green, as you notice, is the color for string literals, which means it's being included as part of the string literal. So whatever we open a string literal with, it needs to close with that. For instance, that just closed it, and now that closes the print from this open parentheses. So this is actually part of the string now, and just to illustrate that, let's run this. I'll save it, and we can see that it actually printed that out, and that's probably not what we intended to have happen. So let's go back and get rid of that. You can mix and match, so as long as you start the string literal and close it with the same one on a different string, I could open that with double quotes and close it with double quotes. However, as a programmer, we have conventions, and by convention, we're going to try our best to be consistent with what type of quotes we're using. Okay, so there's just a couple more examples here of showing some assignments and variable creations. So we're creating two variables here, grade 1 and grade 2, and then we're calculating an average. So remember, the equal sign, we look at the right hand side first and we figure out what it's going to be. So following the same order of operations as we're familiar with in algebra, please excuse my dear Aunt Sally, we do the parentheses first, grade 1 plus grade 2. So we'd add that up, and then we would divide that result by 2, and then ultimately assign that to average. And then down here, we can print out average. So this is a little bit different usage of print than what we've done so far. You can see that there is a string literal, which in this particular editor is denoted in yellow. So it's going to print average, comma, and then we notice we put average here, which is the same as this variable here. So essentially what it's going to do is it's going to print out the contents of that variable, which is what was stored from here. So if you type that in and run it, you should see the average printed out, which is the average of these two numbers. Okay, so that was input. Or I'm sorry, that was output. It's a common task. We're just going to use this built-in function print, and it's going to take that string literal as a parameter. Optionally, it can take another parameter called end. You may have noticed that when we were looking at the IntelliSense. That's a way that we can achieve multiple prints on the same line. Notice when we did our prints here, each one came out on a new line. So if we didn't want that to happen, let's see, let's come back here and look at the IntelliSense. We open this up and we say hello world, close parentheses. We can do a comma, and these things are optional. So sep, end, file, flush, a lot of them not important to us right now, but we're looking at end. And we can see that by default end is this backslash n funny looking sequence of characters here. That's known as the new line character, and that's what actually moves us to the next line there in the output. But we can define another end if we want to, and we can just have that be open close paren. So basically nothing, because there's nothing in between these parentheses, or I'm sorry, quotes. So we'll see how this changes the way that this prints out. F5. Look at how the hello world printed right here. It did not send that new line character, that backslash n, and then when it hit this print goodbye, it printed it on the same line. So I like to think of it kind of as a cursor as we're going through. So originally we were printing hello world, it was sending the new line character, and then the cursor set here and it would hit the print goodbye and actually print that out. Now what it's doing is it's printing out hello world and it's not sending the new line character. So our cursor is sitting here, and when it hits print goodbye, it just picks up from where the cursor's at, sends the new line character, and then prints the next thing on the next line. Okay, so this is just building upon that same thing that we just went over, specifying the n, having it be nothing, so it prints out average right here. And then we can see on the next line, when we go to actually print average, the variable from line 8, it's just printing that out, picking up where the cursor left off. So what about input? Input's just as important as output, right? If we're going to be running programs, we want to be able to bring some data in so that we can use that. So there's definitely many useful programs. As a matter of fact, you can probably think there's not many useful programs if we can't provide our own input to it. It would just basically be doing the same thing all the time. When we input stuff, what we input is always read in as a string. And so what is a string again? That's a series of characters, right? We've been denoting those with single or double quotes. If we want to use what's read in as a number or a different data type, then we need to convert it. And we'll see that here in just a minute. Okay, so the way that we read stuff in is with the input function. Now, there are a couple different ways that you'll see the input function used. There's the way on lines 5 and 6 here where we're doing a print, and essentially what we're printing out is a prompt. We want to ask the user for their name. And then we are going to assign whatever is inputted to the name variable. Now another way we could do that, which is a little bit simpler, is the way that I prefer to do it, is on line 8, we can say that some variable like date equals input date. And this string literal right here becomes the prompt, what's given to the user to show what we are asking for. Alright, so just to make that a little bit more concrete, let's come back over here and let's get rid of some of this. So let's go ahead and prompt the user for a name. We'll do both methods. So the first one, we're going to do a print statement, and we're going to put our prompt out there, and we want for the user to type on the same line. That's a convention that most programs follow. So we're just going to do this end equals nothing, empty string. As we're writing, let's go ahead and run this, test it, make sure it looks good. So yep, we're printing out name, and then the program's ending. Excellent. So let's come back over here. Now let's input that name. So let's say that name equals input. Save that and run it. Now notice it's not giving me the prompt yet. It's actually, there's a blinking cursor here waiting for me to type something in. So I can type in Bob, press enter. Now at this point in the program, Bob would be stored in the variable name. And we can verify that. We can say, okay, hi, comma, because we actually want to print that out, hi, comma, name. Okay, so if we run that, and let's put in Bob, and it says hi, Bob. Cool, so we see how we can bring in a variable, something from the user, assign it to a variable, and then use that variable later on in our program. Now, a simpler way, I think, or at least a way to combine these two lines into one, is to just use the input function. And the input function takes an optional string, which would just be our prompt. Okay, so I tend to think that looks a little bit cleaner, and usually the cleaner solution is the one that we want to use in Python. So if we do that and run it, we'll see that this is functionally equivalent to what we did before. We get the exact same output. Now down here you'll notice a little bit of extra stuff going on. We just did this example where we did some regular inputs. Remembering back to inputs, so coming back here, data is always read in as a string. Now, when it comes to strings in Python, operations that we can perform on strings are different than operations that we can perform on something like a numeric data type. So there's two numeric data types in Python. There's integers, and we'll get into this more next week, but an integer is a whole number, so -1, 0, 1, 2, 3, and so on. And then there's floating point data types, or a float. And what a float is it's a number with a fractional component. So anything that has a decimal place, 1.5, 0.33333, anything like that is going to be a floating point data type. So if we know that we want to do something like compute pay in this case, and we need to multiply two numbers together, then we need for them to be converted to the correct numeric data type. Okay, so let's do an example of why. Get rid of this. Let's go ahead and prompt for hours worked. And we're going to compute pay just like that example. So hours worked equals input worked hourly wage equals wage. Pay is going to be hours worked times hourly wage. And then let's just print back out pay. Okay, so fairly simple. We're asking the user for two things, the hours that they worked in their wage. We're going to compute the pay, and then output the pay. Okay, so let's try to run this and see how this works out. Alright, so we can see down here at the bottom it's asking me for worked, how many hours, let's say 40, and let's say our hourly wage is $10 an hour. Oh, and I get a nasty error message here. So this is our first example of an error. What we're getting here is known as a type error. We know that because it tells us. It says a type error occurred, it happened in this file, which is the file that we're running, and it happened on line 13. So there's not really a good way to get the line number on the side here in idle, but down here at the bottom you can see ln colon like 16. So we're on line 16 right now. If we come back, line 13 is this pay equals hours times hourly wage. We can also see that right here. So Python's letting me know that an error occurred and it happened right here on this line. And then it's going to tell me a little bit about that error. It can't multiply a sequence by non-integer of type string. Alright, so these errors can be a little bit cryptic at first as we're first getting into programming. The more we see them, the more we start understanding what they mean, and it'll become really apparent, hopefully this semester as you're progressing through, what these error messages mean. Now what this one means is it can't multiply a sequence, which a string is also a sequence. It's a sequence of characters like SEQUENCE. So it can't do that by a non-integer of type string. So what we're multiplying here is a string, hours worked, by another string, hourly wage. Alright, so we can solve this by converting these variables to the correct data type. So again, inputs always bring in the data type as a string. If we do not want to use that data type as a string, we need to clarify what the data type should be. And there's some nice helper functions that allow us to very easily change data type in Python. Now let's say, and picking a data type is really up to the meaning of the program. So let's say hours worked. What data type should that be? Well, in the real world, it should probably be a floating point data type because you can work a third of an hour and you can work a half of an hour and you still want to get paid for that. For this example though, I'm going to use a whole number. Let's say that hours work can only be whole numbers 1, 2, 3, up to 40, 50, 60 hours a week. So if we want for this to be an integer, then we need to wrap this input in an integer function. Okay, so what that's going to do is, let's first show you what that looks like, and we see the IntelliSense here is going to convert something to an integer, whatever x is. X is this right here, my input, whatever gets returned from this input. Well, the input has to first give us the prompt and wait for us to type something in and press enter. So then this right here would be replaced in our example with 40, and the string 40, so the string 40 would be converted to the numeric number 40. Alright, so I realize that might be kind of a weird concept, having no programming experience, but that is how the computer sees different data types, and it handles the string 40 differently than it handles this integer 40. Now likewise, as you can imagine, a wage is not always a whole number. You can make $8.50 an hour, you can make $8.75, $9.75 an hour, and those are not whole numbers. So let's use a floating point data type to represent hourly wage. Same concept here, except for we are converting what gets returned from input wage into a floating point number. Okay, so if they enter something like 1025 as a string, it's going to convert it to 1025 as an integer, or I'm sorry, as a float. Alright, so now that we have our data types correct, we shouldn't have a problem multiplying anymore because hours worked is a number, hourly wage is a number, and we can multiply numbers together. So let's do our example again. We run this, it's asking me for how many hours worked, 40, what's the wage, 10, and it prints out the pay. In this simple case, which is why I chose these two numbers, it's 400. Now if we test this, we should be able to try it with some floating point numbers too. So let's say we worked 40 hours, and we make $10.50 an hour. Awesome, it's still calculating the correct result, so $420. Now, what do you think would happen if I tried to put in a floating point number for the number of hours worked? Well, let's see. So, how many hours have I worked? Well, this week I did 39.5. So immediately, as Python's going through and it's executing this code, so it executed this input and it got 39.5, and it substituted 39.5 in for what's highlighted here and tried to convert that to an integer. And what it's saying is, hey, I hit an error here, and here's your traceback, or where it happened. It happened on line 9 in this file. We can see that hours worked equals this, so that is the line in question, and we're getting a value error. So an invalid literal for the int function with base 10. So this is the literal. We talked about string literals. This is well, this is also a string literal, but we want to convert it to a number, and it's an invalid one for base 10 because it's not a whole number. Alright, so that's just something we're going to want to think about. And if whoever we're designing this program for intends for their employees to enter the number of hours worked with a decimal place, then we definitely need to use a float here. We can run that. And we can do 39.5 times 10, and everything works out just fine. Okay, so data types are something that we're going to want to be very mindful of as we're writing our programs. Alright, so speaking of errors, and we've already talked about this a little bit, but they are bound to happen. And you're actually going to spend a lot of time dealing with errors, especially in the beginning as you're learning programming. That's very natural. It's kind of rare to write a program and not experience at least one error as you're going through it. So don't get discouraged if you're getting a lot of errors. Try to understand those errors. Try to decipher what they mean, like we did and when we went through those tracebacks to figure out the meaning of it. Because once you understand what one error is, you'll see that error frequently, and it'll be very easy for you to fix it later on. They can be helpful. We saw that it shows us the line that something happened on, and as long as we know the rules to the language, we can very easily, usually, figure out what the problem was. We're also given that line number, so we can go back and find that line. When it comes to errors, there's two big types. There's runtime errors, which is what we've been seeing. They're called runtime errors because they occur at the time that we run the program. All right, we were actively running that program trying to compute our pay, and we got an error. The other type of error is a syntax error. Now, syntax error is different from a runtime error because a syntax error will not allow us to run the program. For instance, functions we've seen have an open and a close parentheses. Okay, float has an open and close, input has an open and close. If I forget one of those, then I'm going to have a syntax error, which means basically the grammar of my program here in the particular language that I'm writing it in is incorrect. And it's not going to read any further. It's saying I'm done, there's a problem here, I can't figure this out. So if we try to run this, you'll see it doesn't let us run it. It just says invalid syntax, and it actually highlights, this is a little bit deceptive because it highlights the next line. The reason being is it's still inside this float function trying to figure out all of the arguments, and it's just wrapped around to the next line. It's like, hey, I hit a problem here because you never put in this closed parens. Unfortunately, it doesn't tell us that, so Again, it goes back to we need to have a good understanding of the rules of the language so that we can understand why we are getting certain errors. Okay, so if we put that back, we'd be able to run that. Okay, so same thing there. If you remember earlier, I said each statement needs to be on its own line. So in this case, the print statement and this assignment statement, name equals input, are on the same line. To fix this, we would just move this name equals input to the next line, and then we wouldn't have a syntax error anymore. Okay, so a few other common types of errors. Later on, when we get into making decisions in loops, we're going to start doing indentation, which is part of the white space that I talked about, how white space was a big thing in Python that's enforced. If we don't indent correctly, we'll get an indentation error. And of course, that's going to clue us in very easily to what the problem is. We've seen value errors. When we gave an invalid value to the int function, it was unable to convert that. A name error is a very simple error. Just real quick, let's illustrate that. Let's say that I computed pay and I did some other stuff in here, some other code in my program, and then at the end, I'm ready to print out that pay so that the user could see it. But maybe I forgot that I called it pay. There's just a bunch of code in here and I've been writing and just totally forgot. And maybe I thought I called it wage. Well, if we run this, drag this back over, let's try our example of 40 hours at $10. We get ourselves, as you could probably imagine, a name error, and it's saying that the name wage is not defined. This is the first time in the whole program that Python has seen this variable wage. Okay, so I'd want to go back and figure out, was there a typo? Did I maybe have two A's in it by accident? Or something like that, so that we can fix it and not have that name error anymore. And the last type of error here is a type error, and we've already seen the type error, and that happened when we tried to multiply two strings together. That's just not possible. We need for one of those at least to be an integer, and in our case we needed both of them to be a numeric data type. Alright, so that was a little bit longer than what I like to do for the lecture videos, but I hope you guys enjoyed everything. Please go ahead and go through and do the participation and challenge activities. Make sure you go ahead and complete those labs. If you have any questions on those, please feel free to reach out to me. If not, I'll see you guys in the next video. Thank you.